Good morning, everyone. Happy Wednesday. Hope everyone is doing well. So, today we'll be going over some problems and taking questions. So, please ask questions if you're in the chat. So, let's look at the homework. So, I realize I need to put an updated version of the homework on there since when I copied the course, the homework didn't make it over, or at least not the page. So, I'll do that. Let's go over some of the homework. And never fails, as soon as I hit go live, my cat is here. Okay, he left. All right, so the first part of the homework is a lot of definitions, so I'm going to skip that since we did a lot of that yesterday. Well, let's look at these practice problems. So classify each of the following pairs as one of the following. So either constitutional versus trans, enantiomers, or identical, or not isomers. So let's try 5. Everyone take a minute or so, put back on music, and then we'll go over it. So I would start by just writing what these are. So N-pentane, so 1, 2, 3, 4, 5. And then cyclopentane, 1, 2, 3, 4, 5. And now let's write our formulas. So this is going to be C5H. Now it should be 12. Back from our alkane unsaturated rules, but let's just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then cyclopentane, so it has a degree of unsaturation. Just should be C5H10. And so we can see that. So H1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so looking at these, right, they have different formulas. So now that's already our clue that they are actually not isomers. So let's look at the next one. So now we have ethanol and dimethyl ether. So are they isomers or not? Again, take a minute. So what do we think about this one? So let's write out, again, our formulas. So ethanol. And so now this is C2H. So 1, 2, 3, 4, 5, 6. O. And then so dimethyl ether. So ether, 2 methyls. So C2, H6, O. So now, same formula. So they are indeed isomers, and they would be A, constitutional isomers, since they have different groups and different connectivity. All right. So take a look at 7. And what is 7? So looking at these, right, we have a double bond. So we don't have any rotation. And if you remember, so this is cis, this is trans, and so they are cis-trans isomers. So B. So what about the difference between S-glyceraldehyde and R-glyceraldehyde? Any thoughts in the chat? So remember we had that S and that R for handedness. And so these would be enantiomers. So let's look at 9. So 3-methylhexane versus 4-methylhexane. So take a few seconds or so. So let's write out 3-methylhexane. So hexane 6, so 1, 2, 3, 4, 5, 6. So 3, 1, 2, 3. 4-methylhexane, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Except look at this. So this is 1, 2, 3. And so it's actually the same thing. It's just this is not the proper name. And so we could say that these compounds are actually identical. So now try 10. Propanone and propanoic acid. So let's start with propanone. So propane, ketone group. And then propanoic acid. Let's draw propane out. And our carboxylic acid. And so I can already kind of tell by looking at them, but let's write out the formula. So this is C3H 1, 2, 3, 4, 5, 6 O. And this is C3H 1, 2, 3, 4, 5, 6 O2. And so these would be not isomers. Any questions about those? Now for these, I would encourage you to make some sort of model. And so that's kind of the easiest thing. And so we have our models from yesterday with 4 different things. And so this is how I would approach these. So your white is at least hydrogen, so we can orient it that way. I'm going to set my OH as red. So this is going to be red. I'll set the methyl group as green. And then my ethyl group will be yellow. Now I have it oriented properly. And so if I do the same with my second kit, so I'm just going to highlight this. So the cat really wants attention. So now let's orient our other molecule. So it looks like that. And then, so now that we have our 2 structures, my cat is being so needy and creepy. We can compare them. And so now looking at these structures that we made, so yes, indeed, we can try to rotate them, but they are enantiomers. So then you just want to do the same with the next one. So you can orient it. Starting, I have to pick my right one first. So this is the one on the left. Let me make the one on the right. And so now looking at those, so let's see, can we rotate it? Yes, indeed we can. And so these are identical. So this one, we can make our kit for, but we can also tell it's identical. They just have rotation here. We have OH, our methane, and our ethyl group, OH, methane, ethyl. So you just rotate this, and this would be going back, this would be going forward, and this would be in the plane. They are also identical. And what about this last one? Go ahead and make your kit. There's the left one. And then let me make the right one. And so now those are mirror images, so those are enantiomers. Any questions on those? So the molecule kit's super useful. And again, if you don't have one, you can kind of jerry-rig your own. So now let's look at these molecules and then determine, do they have any chiral centers? So let's look at the first one. So it looks like this would be our only chiral center here. It's attached to 4 different substituents. And so if it has one chiral center, right, it has 2 optical isomers, since it could have an R or an S for just that one center. So now let's look at this one. So this one has 2 centers. So this is a chiral center. And this carbon's also a chiral center. So we have 2 chiral centers. So this could be R or S. Same with this one, R or S. So we have 4 different combinations now. Since we could have RR, RS, SR, and SS. So 4 optical isomers. Take a look at ibuprofen. Where is its center? So don't get confused by this carbon, right? It has 2 methyl groups on it, so this is not a chiral center. But this one is, so it would have 2 optical isomers. What about aspirin? Any chiral centers in aspirin? So the answer is no. So right, there are no chiral centers. This is the only carbon that's really attached to 4 different things. This one is making a double bond. So this would be achiral. You'll actually get to synthesize aspirin next week. And then acetaminophen. Any? And so this is also achiral. So now let's do the last one. Draw the enantiomer of each of these molecules. And the easiest thing to do is kind of draw our mirror plane and then just start drawing the mirror image. So that means my chlorine's there, fluorine. And we're drawing the image. Bromine's coming out, hydrogen's going back like that, and there's our enantiomer. We could rotate it and then see that if we rotate it, the bromine would actually be going back. So yes, indeed, they're enantiomers. So let's do the same for this one. So those are our 2 enantiomers. So I hope we're feeling good about this chapter. I haven't been receiving a lot of questions about it, so I kind of assume everything's going okay. Definitely ask questions. We could do some sessions. I'm more than happy to take questions, but I feel like we've covered our homework for today. So I'll go ahead and end the stream, and then I'll hang around in case there are any other questions. And then, of course, feel free to email me to set up individual appointments. So thank y'all. Have a great day.